All right, graphing power functions. Example 4 says describe how to obtain the graph of f of x equals 2x to the 6 from the graph of g of x equals x to the 6th. State whether the function is even or odd, sketch a graph by hand, and then support your answer with your grapher. All right, so let's go through. Let's do our transformations. So describe how to obtain the graph. So I want it in words and be formal. Tell me if it's vertical or horizontal. Tell me if this is a shift or a stretch or a compression, and tell me by what, okay? What's happening, which direction, how many. All right, so let's just go through. We have f of x equals negative 2x to the 6th. So what is the negative going to do to my graph?
Reflect it.
Okay, it's going to be reflection across which axis?
Y.
Yeah, across the x-axis. Remember, if it's not inside with the x, then it's going to cross the x. All right, what is the 2 going to do to my graph? Well, is it horizontal or vertical?
Vertical.
It's vertical because it's not inside with x. It's being multiplied, so it is a stretch or a compression. But if you multiply by 2, remember vertical does what it's supposed to. If you multiply by 2, does something get bigger or smaller?
Bigger.
Bigger, so it's a stretch. Okay? It's a vertical stretch by what number?
2.
Yeah, by a factor of 2. And what is the 6? That just tells me my parent function. It's not a transformation, okay? It just tells me what my parent function is.
Okay, because I know.
All right, so when we go to graph this, remember, think about your parent function, x to the 6th. And we don't really know any numbers for it, but we're just going to create some then. So let's try our negative 2 to positive 2. And so what is negative 2 to the 6th power? 64. First thing, it's negative to an even exponent, so it's going to be positive, right? And then I've got 6 up on my fingers right now. I'm going to count through them. What's 2 times 2?
4.
Times 2.
8.
Times 2.
16.
Times 2.
32.
Times 2.
64.
There you go. See, you could even do it with your fingers, couldn't you? Didn't need a calculator for that. All right, so I got 64. What's negative 1 to the 6th?
1.
1. What's 0 to the 6th?
0.
What's 1 to the 6th?
1.
And what do you think 2 to the 6th is going to be?
64.
Good. Yes. All right, so let's kind of graph these. So we got what? Negative 1, 1, 0, 0, 1, 1. And then 2 is going to be down at negative 2 and positive 2. Whoops. Are down at negative 64. So they're going down really quick, aren't they? So and the thing is...
They're positive. It's 1, 1.
Sorry. Yeah, I realized that. Oh, I know. Hold on. We're not going to graph that yet. What did I do wrong?
You didn't do the other function?
Yeah, that was a parent function, wasn't it? So we could graph that. If we did, well, let's go ahead and graph it so we have our parent function on here. Now, what's going to happen, because, you know, it's going to be a parabola, okay, because it's raised and even. Sometimes it'll look like a W or got a lot of humps in it, but this one doesn't. It's a parent function. But the larger that the exponent is, the flatter it's going to be there at the vertex, okay? So if I do my parent function, it's going to look something like this. But now remember, though, we want to graph this one. So I needed that parent function, though. I needed that table. So what's going to affect my x's? Is there anything inside the parenthesis with the x?
Negative 2.
That's not inside a parenthesis, is it?
No.
So nothing's inside parentheses. So my x's are going to stay the same. So what's going to affect my y? So it's negative 2 times x to the 6, right? So what are we going to do to our y values? Multiply by negative 2. And so, yes, it's just a reflection. And you said it was going to vertically stretch. So if it stretches vertically, it should get more narrow, shouldn't it?
Yeah.
All right. And so it does appear to have gotten a little bit more narrow, and it did reflect across the x-axis.